Okay, hi. This video is going to be proving the log laws. So log laws proofs. And this video is entirely optional. You do not have to watch it for my course. I don't really mind. It'd be good if you did because I think you'll learn something, but you don't have to. Okay, so let's get into it. The first law that we're trying to prove is law number 1, which says log to the base a of m times n is log a m plus log a n. Okay, here also you note that a must be positive and real, and it also, by the way, must not equal 1. Just by the way. Also n and m, similar thing, they also must be greater than 0. Here's sort of the reason why. Okay, what we're doing here is we're saying that a to the power of some number x equals m, and also a to the power of something different, y, equals n. Now remember our sort of graph for this is looking like this. Okay, so the x and y here can be anything. So x, in this case x and y, are just real numbers here because of that. But our answers m and n are only going to be in here. They're only in the positive region. So that's why n and m greater than 0. Okay, so because of this, we can say that that m, so from this, therefore m times n is a to the power x multiplied by a to the power y. Now from our log law, we notice we've got the same base here, so we can say that that is the same base of x plus y. Okay, so now what we're going to do is, so we've got m n equals a x plus y. Now what we're going to do is we are going to, from this step, I need to quickly mention, so just having in the back of your minds, this step implies that log to the base a of m equals x. Also, note that from here, log to the base a of n equals y. It's just the other way of writing this, this first step that we started with. So it's important to have that in the back of your mind. Okay, so back thinking here, we had m n equals a x plus y. Now what we're going to do is we're going to take log to the base a of both sides and see what happens. So taking the log of a from both sides. So on this side we have log base a of mn, and it equals log base a of a x plus y. Now here we know that basically the definition of a log is that if our base is the same as this, then our answer is this thing here up the top. So how do we explain this in other words? Well, just because the log is the thing that undoes an exponential. I guess that's the best way to say it. So this side, so now we have log a mn. Now on this side we've got a logarithm and an exponential. So same base here, so they undo each other. So on this side we get x plus y. Now thinking back to here, this is why it's important that we know these two things here. So now instead of writing x, I'm going to write this, and instead of writing y, I'm going to be writing this. So log to the base a of mn equals, instead of x, I've got log a m, and instead of y, so plus, I've got log a n. There we go, proof complete. Okay, on to the second log law. Okay, so second log law says log of base a of m over n equals log a m minus log a n. And same thing as before, we have a is greater than 0, can't be 1, and m and n are both greater than 0 also. And also similar to before, we're going to say let a to the power x equal m and a to the power y equal n. Both of those things imply that x is log a of m, so this is the same as before, and y is log a of n. That is just the same as before. Okay, what we're going to do here though is we're going to say that m divided by n is, so it's pretty much the same procedure as before, is ax divided by a y, similar to before. Now we're going to use our index law. So the index law says x minus y because we've got a division and the same base. Now we're going to take log to the base a of both sides. I'm just going to write bs for both sides here. Alright, so now we've got log a m on n equals log a of ax minus y. Now here we've got a log and an exponential with the same base going on, and so they undo each other. So because they undo each other, it just becomes the x minus y, just the exponent there. Now I'm going to, instead of writing x, I'm going to write log a of m, instead of writing y, log a of n. So log a m over n equals log a m minus log a of n. And that proof, once again, is done. It's basically exactly the same as the first proof, but starting with m divided by n, using the index law, and so on and so forth. Okay, one last logarithm law to prove. Oops. Okay, this is the log law that says logarithm base a m to the power n is the same thing as taking the n out the front, n log a m. By the way, if anyone has at any point been wondering why sometimes I use capital and sometimes I use lowercase, absolutely no reason, it's just the inconsistency of my writing. So I apologize for that, my bad. Okay, so for this one, we're going to say that we're going to, just one moment. Okay, so slightly different to before. A is still larger than 0, also still not equal to 1. Here, m, we're going to say that m is equal to a to the power x, just as before. This means that m must therefore be greater than 0 also, because of this, like we talked about before. But here we're going to say that this n is going to be sort of a different n. I'm not going to define it in any sort of way. I'm just going to say that n can be any real number, is what I'm going to say here. No restrictions on n. Let's say that we have m to the power of n. Well, that equals, m is a to the power x, so that's a to the power x, all to the power of n. So what that equals then, n, is using our index law, that's a x times n. So next what we're going to do is we're going to So we're going to take log to the base a of both sides. So that gives us log to the base a of m to the power n equals log to the base a of a to the power xn. Okay, so similar to before, we've got log to the base a and we've got an exponential with a as the base, so they undo each other. So we've got log to the base a of m to the power n equals undone xn. Now, back to here, the very top point, I forgot to say that this implies log to the base a of m equals x. So I should have mentioned that. So instead of writing x, I'm going to be writing this now. Instead of writing x, I'll write that. I'm also going to swap positions of these, so I'm just going to say that's nx, as I'm allowed to. So next line, log a m to the power n equals n. Now instead of x, I'm writing this, log a m. And we're done. This is our law that we were looking for. So there we go. There are the 3 proofs of our 3 log laws. Great job for not closing the video as soon as you opened it. Alright, see you in class.